I need to use the power rule. And that is my final answer. So what I have here is an integral. And in order to solve this integral, I need to use separation of fractions, since I have a fraction right here. But before I start solving this integral, I need to rewrite it in another way. So what I'll do is, I have my integral, and I'll write 1/2 multiplied by my function, x squared minus 5, divided by x to the power of 3 dx. So what I really did here is I just removed this 1/2, this 2 here in the denominator, I just removed it. And now we know that this 1/2 is a constant that is multiplied by the function. And this constant I can pull now outside of the integral. So what I'll have now is 1/2 multiplied by the integral x squared minus 5 over x to the power of 3 dx. And now I can start separating the fractions. So what I'll have now is 1/2 multiplied by integral x squared over x to the power of 3. So what I did here is the first term divided by the common denominator. And now minus, let's not forget the negative sign. Second term, which is 5, divided by the common denominator, x to the power of 3 dx. And now while doing this, I can separate this integral into two integrals, since the terms here that I have, this first term and the second term, they're basically added to each other, or one is getting minus from the other. So I can split this integral into two integrals, whereby this 1/2 is basically distributed across these two integrals. And what I mean is, I will have 1/2 multiplied into parentheses, the first integral, x squared over x to the power of 3 dx, minus the second integral, 5 over x to the power of 3 dx. And now the integrals look a little bit complicated. So what I'll do is I'll just simplify them in order to be able to solve them. That means I'll have 1/2 multiply it into my integral. Now we know that the squared cancel the cube. I'll just have an x in the denominator. So what I'll have here is x to the power of -1 dx minus my second integral now. And the second integral I cannot simplify any further. Just rewrite it in another way, which is 5x times x to the power of -3 dx. And now I'll just solve each integral alone. So what I'll have is 1/2 times the solution to the first integral is just the function ln of x plus my constant. I'll call this constant c1 minus my second integral. And for the second integral, I need to use the power rule.
If you got any unsolved problem in the world of numbers and equations, make sure to comment it down below and we can get it solved.
And this rule states if I have a function raised to a power, let's say n, and I need to integrate it, the integral of this will be x divided by n plus 1, whereby n is the exponent, and then x raised to the power of n plus 1, plus whatever constant there is. And the same principle I'll apply now to this function. I'll have 5x to the power of -3 plus 1, which will give me -2 at the end of the day, over -3 plus 1, which is basically -2. And I'll call my integration constant here c2, since this is my second integration. And now a constant plus a constant, so c1 plus c2 is just equal to a constant. So that's why I'll add these two constants together, giving me only c1 and c2. So I'll have 1/2 distributed across ln of x minus, and now I'll just simplify this. I have the negative and the negative here in the denominator, which will just give me a positive. So plus 5 over 2 x to the power of -2 plus c as a constant. And I know now that if I multiply whatever integer with a constant, that'll just give me a constant. So I can remove this constant outside of the parentheses. I'll have as a final answer ln of x over 2 plus 5 over 4 times x to the power of 2 plus c. And that is my final answer.
Don't forget to subscribe to Sam's Education channel and hit the notifications bell to receive regular updates and access to a variety of solved exercises. See you in the next video.